5, that's the question mark, and that's true. So it's going to run all these, and then come back, and then continue on in the D indent. So all this stuff is running, right? And then it says f x equals 6. Well, that was false, so that skips all of them. So none of these lines of code run. So these actually don't run, and it says afterwards 6. So that's a mistake. Those don't run right there, okay, because x is not equal 6. Okay? So indentation is an essential part of Python. We use indentation in lots of programming languages, often to kind of demarcate blocks, to show where blocks start and stop. But in Python, it's syntactically correct. You can make an error if your indentation is wrong. After an if, you must indent. And you maintain the indent as long as you want to be in that same if block. And then when you're done with the if block, you reduce the indent. In this rule of indenting, comment lines and blank lines are completely ignored. So we're going to tend to like put 4 spaces. 4 spaces ends up being the normal thing that we do, and you'll see all the code that I write has 4 spaces for each indent. If I go in twice, I use 8 spaces. And we have this instinct of wanting to hit the tab key to move in 4 spaces. Now the problem is that it might look the same on your screen. A tab and 4 spaces might line up the same place depending on how tabs are set. But Python can get confused by that. So we tend to avoid using actual tabs in files. And so most programming text editors, like if you're using Notepad or Text Wrangler, there's a place to set the tabs to say don't put tabs in this document, but every time you hit a tab, move over 4 spaces. And so you hit a tab, but it's like space, 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 space. Now the nice thing about Atom, and this is the text editor we tend to recommend in this class, because it works on Windows, Linux, and Mac, but also because it automatically sets this up. As soon as you save your file with a .py extension, you can sort of hit the tab key with impunity, and everything works perfectly. But the key thing here is that Python insists that you get this right, and if you don't get this right, you're going to get indentation errors, and they're just another syntax error. So if you're using something like Text Wrangler or Notepad, hunt around in the preferences and you'll find something about expanding tabs, or maybe how many spaces each tab stop is supposed to be. And so you check these, and what this really is doing is telling your text editor never put an actual tab in the document, but somehow simulate tab stops using spaces. And so here is a bit of code. It's got a nested block, but it gives you this sense that you have to be very explicit when you're reading Python code of whether the indent is the same between 2 lines, the same, increased or decreased. And so every time you increase it, you mean something, and every time you decrease it, you mean something, and literally if it stays the same, you mean something as well. And so if we take a look at this, here we have a line, and the next line has the same indent. This is an if with a colon at the end, so we have to increase the indent, and now we're maintaining it, okay? So these 2 lines are part of that if, but now we have de-indented. So whether you choose to de-indent this word or whatever, where you do this de-indent affects the scope of how far this if statement lasts, right? It lasts up to, but not including, the line that's de-indented to the same level as the if. Okay, so this is a de-indent. Now we have a blank line, which doesn't matter, and we maintain it. Now we have a for, which we'll learn about in the next chapter, which is a looping structure. Let's do a for runs this 5 times. It has a colon, and it also expects an indented block. Now we have what's called a nested block, where we have an if and a colon, and we go in some more. So this is like 2 indents, right? So these are 1 indent, and these are 2 indents. And so this is a block within a block. And then we de-indent, so that means this print is not part of the if statement, but is still part of the for statement. And then we de-indent again, and then that means this print is sort of on the same level as that for statement. So if you start thinking about this, you want to be able to start thinking that these blocks are the start of the block with the colon line up to but not including this line that's been de-indented. So the for goes this far, right? The for goes up to but not including the line that's de-indented. The if goes up to but not including the line that's de-indented. So as you do this, you'll sort of mentally start drawing these blocks. And pretty soon you will start constructing them as blocks. And it takes a while, but doesn't take forever. But in Python, unlike other languages, oops. In Python, unlike other languages, you have this is very important and it matters, and you can have syntax errors if you get it wrong, because you're really communicating the shape and structure of your code using these indents and de-indents. We already saw a nested indent. This is a nested if, so you can put an if within an if, and you can go as far deep as you want to go, like Russian dolls. And so here we have x equals 42. If it's 1, we indent 1. And then with this next thing we do, these are at the same level of indent, but now we see an if, and it has to indent further. So this is like 2 in, 8 spaces. And then we de-indent back. Actually, we de-indent back 2. And so if you watch this and you take a look at how this works, it runs to here. Oops. Back up. Comes in here. The answer is yes, x is greater than 1. Prints this. Is x less than 100? Well, it's 42, so the answer is yes. So it runs this, and then it kind of continues back to there. And you can also think of drawing boxes around this. This is one if box, and then within that if box there is another if box. And again, it's the indent block up to but not including where the de-indent happens. And this here is like 2 backwards de-indents. So it ends 2 blocks. So 2 blocks are ended by where we place this. We could move this in, or we could move this out. We could have it all the way into here, we could have it to here, or here. And where we put that line depends on how the ends of these blocks are going to work out. So one form of that's a 1 branch if that we just saw, but then you can also have what's called a 2 branch if. And the basic idea of a 2 branch if is that you're going to come in, you're going to ask a question, and you're going to go one direction if it's yes, and another direction if it's no. We call this an if then else. It's kind of like a fork in the road. And the way to think about it is, depending on the output of this question, we're going to pick 1 or 2 of these, but if we pick one, the other one's never going to happen. So it's like an either or. We're either going to go one way or we're going to go the other way, but there is no path where we somehow go boot through both of them. That doesn't happen. And the syntax that we use for this is what we call the if then else. And so the first part is a normal if with an indent, and then we de-indent, and then this is another reserved word, else, with a colon, and then we re-indent. And so this is really end up being part of a whole block here, and the else is the part, this is the part that runs if it's false, and this is the part that runs if it's true. The first branch of the if, the first indented block is what runs if it's true, and the second indented block is the one that runs if it's false. And so here we go, it's just if x is greater than 2, in this case it's yes, we're going to print bigger, and then we're going to be all done. And so we do 1, and so this one did run and this one did not run. So basically with an if then else, one of the 2 branches is going to run, but there's no case in which both branches run. And again, you sort of draw these blocks around these things mentally, and in this one you sort of take from the if, not the else is really part of the block, up to but not including that print, which is back indented, de-indented back to the same level as the if statement. Okay? This Python is actually one of the more elegant languages, even though after a while this indenting, and when you get too far in, it gets a little bit complex, but this is a good way to visualize this with these indents. Coming up next, we're going to talk about some more complex conditional structures. So welcome back. Let's talk a little bit more about some more complex conditional statements that sort of build on this concept of if and if then else. The first thing we're going to look at is the multi-way branch. And so the idea is it's kind of like the if then else, where you're going to pick one of 2, but now we can pick one of 3 or one of 4 or one of 5. And it introduces a new concept called the LF. The LF is another reserved word inside Python. And the way it works is it's probably best to look at this here, where it checks the first one, and if it's a true, then it runs that, and then it's done. It doesn't check them all. It's not like it sees that there are 2 logical conditions. It actually checks them, the first one, and how you order these matters, as we'll see in a bit. And so if the first one is true, it runs. If the first one is false and the second one is true, it runs this one and it's done. And if the neither of them are true, it falls through, and there's an else clause that is otherwise, and it runs that. So basically, it's either going to run one and then skip the other two,